of cosine. The other way, besides finding triangle parts through law of sines, this one has different configurations. So we'll use law of cosines when I have side situations, or a angle side situation is when I can use the law of cosine. So let's see how we get it. So here we have our triangle ABC. Notice it's in standard position. So we've got, okay, then this is there. We're going to do the derivation part. So we've got our triangle in standard position where one of the sides is lying on the x-axis, one of the vertices is at the origin, and then we have these known coordinate values, 0, 0 for C because you're at the origin. Vertex of B is lying on the x-axis, so if we call A this distance of my triangle on the x-axis, we get A of H0 for that coordinate for B, and then we get this unknown coordinate for A, D of H. Just going back to our trig definitions, the cosine of some angle is equal to the x over the hypotenuse, in this case the d over the b. So that's what's happening right here, which means we find the d value of that little triangle as being to b times the cosine of that, or cosine of c. And doing the same thing for h, using sine of c, sine being h over the hypotenuse of b, and then solving this one for h, we get h equals b sine c. So those are the now new coordinates that I have for d and for h. Right, so then what we're going to do is we're going to find out this distance here from A to C. So, or maybe we can go this way. Go distance from A to B, for example. Line segment AB is equal to this C value. And we can use the distance formula. So distance formula says take your difference in x's and square it plus your difference in y's squared. So our generic just fill everything in. So let's do our x's. We'll call this x2, y2, and then this will be x1, y1. Bless you. All right, filling everything in. Square root of x2, b cosine of c minus a squared plus b sine of c minus 0 squared. Just filling in my x2, x1, y2, and y1. Now we simplify this. And we get b squared cosine squared c minus 2ab cosine of c plus a squared. That's just spoiling b cosine c minus a. And I add that. b squared sine squared c. And then that's it. Because I don't do negative 2 times 0 times b sine c, because that just becomes 0. Oh, what? Yeah. Scroll back up. Okay. Good? All right. So then we look down here, and we have, let's see underneath, we've got, here we're going to separate things just a little bit. I'm going to go like this, b squared cosine squared c plus b squared sine squared c minus 2ab cosine c plus a squared. Take a look at that pairing right there, b squared cosine squared c plus b squared sine squared c. Trying to get a Pythagorean identity to fall out of that. What would I have to do?
Factor out the b squared.
Factor out the b squared. Yeah, so look what happens. If I factor b squared out of this, I get cosine squared c plus sine squared c. That equals 1. Minus 2ab cosine c plus a squared. And this is still all under the square root. So this whole thing just becomes 1.
B squared.
Yeah?
No.
And then I get that c squared would equal b squared minus 2ab cosine c plus a squared. And this is actually the first of 3 different ways you can write the law of cosine.
Control.
Oh, why is it not under the radical? Good question.
Yeah.
So it was under a radical and it was just a c, right? I made it c squared, so I took the radical away, squared everything on both sides.
See the law of cosines.
Scroll up.
Yeah.
Gotcha. So here they are. Here are our 3 law cosines, just like we had for law of sines. We had 3 different ways you could express it depending on the angle that you had. It's the same thing for law cosines. If I knew angle A, I'd set it up this way. If I knew angle B, I'd set it up the second way. If I knew angle C, I'd set it up the third way. Or, if I didn't know any of the angles, and I just knew all the sides, then I'd pick one of those to set it up. So side, side, side configuration, 4 side, angle side is how I'm going to use the law of sines. Now the second set of change that you see going on down here, this is what we do when we want to actually solve for the angle. Law of cosines sets up to solve for a side. Sometimes we need to go find the angle, and that's what's happening here with this step. So we just chose the bottom one, c squared equals a squared plus b squared minus 2ab cosine c, and we're going to go find cosine c. We're going to go get that thing by itself. So the first thing we did is we subtracted a squared, we subtracted b squared, and we got that. And then to get the cosine c by itself, we're dividing by negative 2ab on both sides, allowing us to have just cosine c. And unlike our law of sines, friend, which gave us the possibility of 2 angles, why won't we have, or 2 triangles, why won't we have that for this?
Because the cosine is positive below.
So cosines are only positive between 0 and 90 and 270 to 360, and we can't exist with negative angles for our triangle, so we don't even consider a second angle for cosine. It's not true of sine. Sines can be positive at angles 0 to 180. So these guys do not have any ambiguous type of a case. They're pretty straightforward. And then solve for the angle C, do the inverse cosine of that big mess, and now you can actually find the angle having known all of the sides. So there are the 2 different ways we can use the law of cosines, finding sides versus finding an angle.
So is that all that can be derived of how?
That's just a derivation of the law of cosines, where it comes from. Okay, so let's go, everyone good on that, writing that down? So let's go apply some of it. And now here's what you're going to have to start doing. You're going to have to start giving the triangle to determine which law you should be using. So obviously all the stuff tonight, probably because we're talking about law of cosines, will be law of cosine setup. But there will be other problems in our application where you're going to have to determine based on what you see, do I use law of sines or do I use law of cosines? So you just got to know the configurations. The majority of sides known, with the exception of the ambiguous case, means you have law of cosine. So side angle side or side side side. When that angle is not included and you have two sides, then you have the SSA or ambiguous case for the law of sines that you have to consider. So just pay attention to that. So here we have a side angle side setup. Looking for this opposite side of x. Not a right triangle, so I just can't do any simple right triangle trig. So we go and we set up our law of cosines. Now, again, it doesn't matter which one of those three that I'm using. A squared equals b squared, it doesn't matter. Just understand that if you have relationships with sides and angles, I set it up like so. I'm looking for an unknown side. I need to know its angle. So we won't worry so much about the A, B's, and C's. Generically, we'll just start with an equation. So we'll just start with this one. And it's actually fairly straightforward in terms of memorizing it. So a squared equals, well, the two other sides added together, the square of the two sides, b plus c, and they're squares. And then the part that gets included with the cosine is the -2 of whatever those roots are. So bc, b squared, c squared. All right, we fill it all in. In this case, we're looking for x squared. And it doesn't matter which of these 4 or 9 that we call a or b. So 4 squared, 9 squared, 2 times 4 times 9, cosine of 110. This is going to give us x squared, so we just have to remember that we need to take the square root of this whole mess to come up with our answer. So 16 and 81, 97, minus whatever 72 times the cosine of 110 is. What am I going to get there? Then be careful, right? Those stick together. So think of my order of operations. I don't do 97 minus 72 and then get that answer times the cosine of 110. I got to do 72 times the cosine of 110 and subtract that from 97. So what am I getting here?
Overall?
No, on just the 97 minus 72 cosine.
121.6.
Okay, and then that's x squared, so I'll just make sure I square root that.
11.0.
All right, and we don't have any units here. And this is an approximate answer. It's not exactly 11.
It's 11.
And there's log cosine. So just make sure you don't forget to take the square root there at the end of these things. So you can see once you have the formulas down, this stuff's pretty basic in terms of just plugging and chugging. It's kind of like a recipe, right? Just Gary, put your phone away. Triangle number 2. No visual, just some sides given to you. You draw the triangle, and then we go find all the information related to it. Always a good idea. Draw the figure. Don't ever make it a right triangle. Don't assume that it's a right triangle unless you know by some angle given to you that it is. So we got to go find our smallest angle, which is going to be across from which side? The 6. It's going to be across from the smallest side. So, all right, we do our best to kind of draw some sort of a to scale model. So that would be our 6. would be our 12, this would be our 15, and for the sake of labeling, let's say we're looking for angle C, because that's going to be our smallest angle. Okay? So we set it up. All sides given. So now I'm going to go and why did I choose to set it up that way? Because I'm trying to find the angle C. So I have to use the law of sine, the law of cosine setup that has the C to begin with. And you can do one of two things here. You can plug everything in and then move things around. Or you can go ahead and move things right now and just solve for C that way. And so I'd say let's just move it all around. Subtract a squared, subtract b squared, divide by negative 2ab, and then do the inverse of that. So angle C is the inverse cosine of c squared minus a squared minus b squared all over negative 2ab.
Wow.
And then fill it all in. So somebody shout out an answer here for me when you...
An answer.
That's hilarious.
Okay.
Now, you got to pay attention. What is C? C is 6. So I got 6 squared minus 12 squared minus 15 squared, although negative 2 times 12 times 15. So you just have to be careful which A's and B's and C's are when you're plugging this stuff in. I just assigned it like that, yeah, and that really wouldn't matter how you arbitrarily pick what vertex A, B, and C. So if you'd assigned your C up here instead, you're still going to have the same.
22.3.
Sorry, it's what?
22.3.
So 22.3 degrees.
Yeah.
You guys get confirmation on that? Is that right? Just, again, don't try and put it all in at one time. Do it in chunks. So find all of your length of sides differences, get a number. Then do your negative 2 times AB and get a number. Divide those two, and then take the inverse cosine of that. Don't try and do it all at once. Did we get that, you guys? Yeah? You're not getting that? You are, okay, you are getting it. All right. And then find the length of the median to the longest side. Uh-oh, definition. What does median mean?
Median cuts it in half. It's the bisector.
Okay, good. Does it make a certain type of connection?
Yes, it's perpendicular bisector. It intersects at a 90-degree angle.
Yeah, it intersects at not necessarily a 90-degree angle. It simply intersects at the midpoint. It does not.
Except for it's
No, you said 90-degree angle.
No, I said that the first time, and you're like, oh,
What?
oh wait, I'm not right. Yes.
So the longest side, we're talking about that median right there. We're going to the longest side. All right, so if we're supposed to intersect and find the length of this thing, that means we're going to be doing some distance formula stuff. If I'm going at the midpoint, that means I've split this into two congruent pieces of 7.5 and 7.5. I've now found angle C to be 22.3. So how am I going to go about finding the length of this thing? Anyone have any ideas? There's my triangle I probably would look at, but which law would I have to use now? Law of sines. Because I'm looking for, well, do I have it up? Actually, I can't use law of sines, can I? I gotta use law of cosines again. Because I'm looking for this length here, we'll call length x. I have a side, angle, side, 12, 22.3, and 7.5. So I got to do law of cosines again to find out this length of x. If I had another angle given to me, if I had angle, well, yeah, if I had another angle, I could go ahead and use law of sines. I was missing an angle, so I can't use it. So I'd have to set this thing up, find out my x to log cosine. So it would look like this. X squared is equal to 12 squared plus 7.5 squared minus 2 times 12 times 7.5 cosine of 22.3, and then I take the square root of that whole thing, and there's my answer for how long it is. What's up? All right, anything on that, question-wise? You did what? How'd you set it up? Just say. You did B over here, and you did C right here. Okay. Now, if you did that, then you would have had 6 right here, right? Because your C has to be across from the angle that you have. So I have to move my 6. All right, so whatever that answer is obviously what x is going to be. All right, I'll leave you with this. We're going to stop it right here, see if the recording works.
Probably not.
Probably not. Parallel, before we kill it though, parallelogram, diagonal lengths 20 and 12. If they intersect to form a 60-degree angle, find the perimeter. All right, so we're looking for the length of this thing all the way around. You guys want to give this one a shot?
It's dot. Where's dot? It's a 60-degree angle.